Hello, everybody. Welcome to section 2.3, part 2. We're talking about using graphs of functions, and today we're going to be going over how to solve equations and inequalities graphically. So, solving equations and inequalities graphically. So let's look at like the general rules first. So when we're looking at the solutions to equalities, so solutions to, if we have two functions that are equal, right? And sometimes our second function, like g of x, can be a constant. So this could be like f of x equals 0 or something like that. Like that is included in this case. This is where the graphs cross. So for example, if we have our coordinate plane here, x-axis, y-axis, and we had maybe some function like f of x that went like this. This is our f of x, and then we had another function, this, call it g of x. The solutions to this equality right here are exactly where they cross. So it's right here and here. And so if you drop down to the x-axis, these are the values that you can plug into both functions, and you expect to get the same result. So that's what equal means. So those are our solutions. Cool. Now solutions to inequalities. So let's say f of x is greater than g of x is where the graph of f of x is above. And it's above because it's a greater than sign above the graph of g of x. So if we look at that in pictures with our x-axis, our y-axis, and let's draw the same functions. Let's do f of x looked like this, and g of x looked kind of like this. So if we're looking at the solutions to this thing, that's where f of x is above g of x. So in this case, we have f of x is above it on this side and over here. So if we drop these points down, since we're looking at strictly greater than, we're not including the endpoints. But if we were looking at greater than or equal to, we would include the endpoints, and then the solutions would be going off infinity like that. Assuming, of course, that f of x stayed above g of x. So yeah, let's look at maybe some examples as to how to apply this. So example, solve the following graphically. So let's let our first one, and if I ask you to solve something graphically, I will give you the graphs of them. I'm just providing the equations for some context. So if we looked at, oops, that is not a straight line. That's a little bit better. Okay. So what we're going to do is we're going to let this be our f of x. We're going to let this be our g of x. And so we graph these. So the blue one is going to cross here. It's just going to go this, just a simple line. And then our parabola looks something kind of like this. And I will also tell you what these points are. This point is supposed to be, if this were drawn to scale, 2, 3, and this point is supposed to be -1, 0. So if we want to solve when these are equal, we're going to look at the points that they cross. So the first point is right here. The second point is right here. And if we drop this down, that's at x equals 2. And this one is at x equals -1. So the answer to this equality is x equals -1 and x equals 2. Good, pretty straightforward, right? Just look at the picture, look where they cross. It'll all work itself out. So let's look at maybe an inequality. Let's maybe look at, and this is going to look a little scary when I write out the equation for this. But don't worry, we're not going to have to solve this by brute force. We are going to use this nice picture that I'm going to attempt to draw in a clear fashion. X, Y, and then and so if we're going to let this over here be our f of x, and our g of x is going to be constant function 0. And so if we look at this polynomial, it graphs roots here, here, and here, and it looks something kind of like this. So that goes off to infinity. This curves around like that. And then if we were to graph the g of x equals 0, that's just going to be the constant function at y equals 0, like that. All right, and so now, since we're looking for where f of x, the blue, is greater than g of x, the red, we're going to look at where the blue is above the red. So see that kind of happens here and over here to infinity. So because it's strictly greater than, open circle, in between, open circle, all the way off. So the solution for this one, the answer will be, this first interval is at 1, 2, -3, 0. This one is at -1, 0. This one is at 1, 0. So our first interval is going to be -3, -1, unioned with, and then 1 to infinity. Excellent. Let's do one more, just for completion's sake. So let's do -x² + 7, and let's do greater than or equals to x² - 1. And again, I'm going to let this be my blue f of x. I'm going to let this my red g of x. And let's see if my graphing abilities are up to par. Not my graphing abilities, really my artistic abilities. So. And so if we graph the blue, I believe it'll look something like, so 1, 2, 3, 4, 5, 6, 7. It'll be here, and then it'll go down, and it'll hit about right like here or so. It's a really terrible parabola. Just trying to make it symmetric too. Okay. Luckily, these do not have to be pretty for us to be able to find where they cross. And I already know they should cross at 2, 3, -2, 3. So when I draw this, it's going to go like that and like that. So those points again were 2, 3, and -2, 3. Okay, and so we want to know where the blue is greater than or equal to the red. So that's where the blue is above or at the red. So that's kind of here. So if we drop this down, this time we're going to use closed circle because we're doing greater than or equal to. So we also want to see where they cross, right? So closed circle there, closed circle there, where they're equal, and then where the blue is greater than the red is in between. And so if we were to write this answer out, the answer would be, this is -2, this is +2, so it's going to be closed bracket, -2, 2. All right, pretty straightforward. Yeah, so finding solutions to equalities and inequalities graphically is actually pretty straightforward, especially if you're already given the picture. All right, keep working on your homework, and I hope to see you all in office hours.